there are some examples as well. So you can, if you want to look into different, examples of OpenDSS, you can look into that. There is manual also. I think this is a manual. Okay, and you can look into this IEEE test cases as well. So let's say that I want to open this 13 bus feeder, which is IEEE test case. So you go into open in 13 bus feeder. So there are two things like this IEEE nodes, open this IEEE node circuit. So each of these OpenDSS files always look like this DSS file. The file type is DSS. So if you open this 13 node system, then it looks like this. Now I will go into more details about how this model has been done. But just to give an example, so suppose you have this OpenDSS model, right? And you want to just run it. Then you do like Control A. So Control A kind of, selects the whole thing, and then click on write and then do selected. So what it does is that do selected means, you have the certain, lines of code and do whatever is written there. Now, why I'm doing do selected is, what it does is that it solves the power flow and it calculates voltage and everything, right? So, and Control A, do selected. So then it runs power flow. It is as simple as that. So on the left hand side, you see a lot of, this is a summary, right? Like what kind of active power there is. So there is 3.56 megawatts, which is coming in from the substation side, reactive power, active power losses, how much it is. So everything is written. Now, suppose, just to give you an example, now suppose after power flow, you want to see the voltages, right? So you go to show, in show, if you go to voltage, and if you want to see line to neutral voltages, so go to voltages, line to neutral, then it will show this file, right, where it shows, where what's the voltage value as well as angle of each of these nodes. And similarly, you can do the same thing for currents as well. So show currents, or if you say, let's see power. So power's kV element means it will show element wise power. So it says that how much of power is being flown in from the source bus, what is the power factor and everything. So it will show element wise, power factor, power flows and everything. You can see the same thing for current as well. So it will also show current element wise how it all looks like. But I'll go into more details about, how to model this whole thing, what each of these lines actually mean, because understanding each of these lines makes some sense. And if you have any problem about, suppose you don't know how to look into this, right? So if you go to help, go to DSS help, and in DSS help, it has everything. So if you want to look into, say, show, right? So in show, you can suppose I'm looking into voltages. So it shows that, how voltages will look. So you have this 4 options that you can put in. So this help really works. So if you have any questions or anything, that particular command that you look up to, you can go to DSS command and in the help, and then use it. So it's in help. So yeah, so I think I'll stop here and then we can start from tomorrow on. So tomorrow I will talk about more about how each of this line actually means. I'll give a brief description, but it will be pretty easy for you to understand. And then we'll try to shift a bit more on DR models and optimization. I'll see how much time I get.
Okay, well, there are some questions in the chat, so I think first one I can take, and then you can answer others, Nilay. So first one is PSS sync call can be used for distributed system modeling. So yes, definitely it can be used. It's one of the commercial software used by industry, and you know, every software has advantage and limitation, right? So OpenDSS also has, I'll let Nila explain that, but in Syncall or any other software which is owned by industry, the limitation is that typically you cannot modify your own model much, right? And even if the problem happens, you cannot debug. So you can use the software. You cannot participate in developing something to integration with any industrial software, right? Either it's ETAP or Siemens or of course, Syncl is a very mature tool, but with the same limitation that you cannot develop your own DR model with more complexity for some behavior that you want to model and add that into that. So I will let Nilay answer next three, and then tomorrow I will not join, but Nilay will be showing OpenDSS for distributed system modeling and also give short lecture on DER and then also how to model that.
Okay, so the next question is, although OpenGIS is open source, does it have any limitations with respect to analysis worth mentioning, PFY, basic version? Yeah, OpenGIS is open source, and I'll say the limitations is all these distribution system softwares that you have, like simulation softwares, the major disadvantage is its visualization. So visualization in the sense that, suppose if you have these 5 feeders in Jammu, right? And if you want to do a huge simulation and you want to see voltage of all nodes throughout different seasons, throughout different years and everything, right? So there is no dedicated button like that where you can, visualize this whole thing properly. So what you have to do is that you have to run OpenDS, like these models again and again in OpenDSS, export that file in CSV form and everything, and try using visualization softwares like Tableau and all of that. Tableau, or you can do it in Power BI as well as that, all of that. So utilities have that problem with visualization. OpenDSS is not a very hands-on software. So like SIME, which is a industry grade software, you have this whole model, right? So then in each block you have, suppose there's solar power generation. In the model, you go click in the model and then you change a setting, right, on the PV system or generation like that. But in OpenDSS, you have to go through the code, change a certain setting, and then run the power flow again. So it's not very hands-on. It's not a very user-friendly software. Both OpenDSS and GridLab are not user-friendly in the sense that you cannot visualize pretty properly. You cannot change models just by clicking into it, where most industry-grade softwares are. So these are its most basic limitations. The other limitation that OpenDSS has with respect to GridLab. So GridLab is a very dedicated distribution system software which can go into very detailed model of your own house. Suppose in your house you have different kinds of loads, like it can be refrigerator, it can be thermal loads and all of that. So you have like 10 different appliances in the house, right? So you can actually model those 10 different appliances, like thermal models and everything. So GridLab provides that platform to do a very detailed load model of a particular house, not a house, but a commercial building as well, which is not possible in OpenDSS. The basis of using OpenDSS is that if you have a huge feeder of your own city, of your own town, or you have multiple feeders, or you have multiple substations, then you can, run the system, run power flows, and check voltages or check different parameters of the network. But again, you have to use different softwares to visualize it. And graphical representations of waveforms is possible in OpenDSS. So when you say graphical representation, are you talking about phasor waveform? Phasor waveform is not possible. But in OpenDSS, suppose you run like a day of, suppose you have a feeder, and the feeder load looks like this, like a profile. You give that profile to OpenDSS, and then it can show voltage, current, power, and everything throughout the whole day, right? Depending on the load profile. That is what you can get. Now by waveform, the RMS voltage or the per unit voltage or current you will get. It won't be in the sense that, whether it is sinusoidal or not, whether it is, obviously OpenDSS takes that into consideration, that it is sinusoidal. It doesn't have any, uh, issues with that. But OpenDSS is also a software which is expert in harmonic analysis. So that is a different situation. So OpenDSS also does a really good harmonic analysis of a distribution feeder as well, in terms of that it can calculate sequence currents, voltages. It can look into harmonics of currents and voltages as well. So that is a different topic. But apart from that, if you say that I want to see the voltage or current waveform of a phasor, about how it looks like, it's not possible. But you can run a distribution grid model over a month, seasonally, yearly, hourly, and look into those, power profiles, current profiles, voltage profiles, all of that. Okay, link to download OpenGSS. So here is the link. So go into SourceForge, just click on the green. Let me show you. Um, so basically, so go into this website. Just click on download. The green thing that you have. Download it, and that's it. And then it's a pretty easy software. It's nothing there. So, and then you go into the. So when you then download OpenDSS, then OpenDSS will probably be saved in program files or something like you can define on your own. And then within OpenDSS folder, you can have those test cases, manual, and everything. You can even find OpenDSS manual online. So I think I've put all of this thing in the PowerPoint presentation, but obviously I can share it again. Is the real-time simulation possible, like integrating OpenDSS? Yeah, OpenDSS and Typhoon Hill is possible. I think OpenDSS OpenLRT, whether it is possible or not, I think Dr. Srivastava can tell. But OpenDSS Typhoon is possible. Yeah, we just recently got a Typhoon Hill software, and then we are trying to integrate OpenDSS in that. But that is possible, and Typhoon has that availability to connect to OpenDSS.